My name is Julian.
My name is Robert.
My name is Raymond.
My name is Marco.
And our project is on the life cycle of massive stars. Well, the life cycle of massive stars starts in a nebula, and a nebula commonly consists of about 7% hydrogen, 28% helium, and 2% of heavier elements. When an outside force such as an explosion of a nearby star compresses a cloud, and some of the particles move close to each other and are pulled together by gravity.
The second and longest stage in the life of a star is the main sequence stage. During this stage, energy continues to be generated in the core of the star as hydrogen fuses into helium. Fusion releases enormous amounts of energy. For example, when only 1 gram of hydrogen is converted into helium, the energy released can keep a 100-watt light bulb burning for more than 200 years. A star that has a mass about the same as the sun's mass stays on the main sequence for about 10 billion years. More massive stars, on the other hand, fuse hydrogen so rapidly that they may stay on the main sequence for only 10 million years. Because the universe is about 14 billion years old, massive stars that formed long ago have long since left the main sequence. Less massive stars, which are at the bottom right of the main sequence on the HR diagram, are thought to be able to exist for hundreds of billions of years. The stages in the life of a star cover an enormous period of time. Scientists estimate that over a period of almost 5 billion years, the Sun has converted only 5% of its original helium nuclei into hydrogen nuclei into helium nuclei. After another 5 billion years, though, over 10% of the Sun's original hydrogen converted fusion will stop in the core. When fusion stops, the Sun's temperature and luminosity will change and the Sun will move off the main sequence. A star enters its third stage when almost all of the hydrogen atoms within its core have fused into helium atoms. Without hydrogen for fuel, the core of a star contracts under the force of its own gravity. This contraction increases the temperature in the core. As the helium core becomes hotter, it transforms energy into a thin shell of hydrogen surrounding the core. This energy causes hydrogen fusion to continue in the shell of the gas. The ongoing fusion of hydrogen radiates energy outward, which causes the outer shell of the star to expand greatly.
Go to star now.
As gravity makes these dense regions more compact, any spin the region has is greatly amplified. The shrinking spinning region begins to flatten into a disk that has a central concentration of matter called a protostar. Gravitational energy is converted into heat energy as more matter is pulled into the protostar. This heat energy causes the temperature of the protostar to increase. The protostar continues to contract and increase in temperature for several million years. Eventually, the gas becomes so true for several million.